Hello, we have discussed some problems on sections of solids with section plane perpendicular to VP and inclined to HP. Now let's look at some problems on section plane which is perpendicular to HP and inclined to VP. Okay, in the former case, the section plane was perpendicular to VP. That means we can see the section plane as a straight line in front view. Okay, so in this case, now the section plane is perpendicular to HP, so that we can see the section plane as a straight line in top view only. Right. Let's look at the question. A pentagonal pyramid, 30 mm base edge, edge of base and 60 mm height, stands with its base on the ground. Okay, the pentagonal pyramid is resting on HP or ground on its base, and an edge of base perpendicular to VP. That means one of its edge in this figure, I have placed AE as perpendicular to VP. AE is now perpendicular to VP. That means in top view, AE is perpendicular to XY line. Right. A section plane perpendicular to HP and 30-degree inclined to VP cuts the pyramid. Okay, the section plane is perpendicular to HP. Okay, note down the question. Section plane is perpendicular to HP. That means a plane which is perpendicular to HP, we can see the plane as a straight line in top view. That means that top view gives the horizontal trace of that section plane. That means whenever the section plane meets the horizontal plane, the intersection will be a straight line. That straight line is actually the section line. Okay, that means that line is actually horizontal trace of that section plane. So we need to mention that section line is horizontal trace. Okay, now the question, section plane perpendicular to HP and 30-degree inclined to VP. So if the section plane is perpendicular to HP, we can see the section plane as a straight line in top view, and also that plane is 30-degree inclined to VP. We know that whatever the dimension, whatever the relation with respect to VP is only visible in top view. So we can see the section line in top view of this figure. Okay, in the former case we have drawn the section plane in the front view, but in this case the section plane is perpendicular to HP, so which is only visible in top view. So the section plane will lie on the top view of the figure. And this section plane cuts the pyramid at a shortest distance of 5 millimeter from its axis. Right, the position of the section plane is given, that which is 5 millimeter from its axis. Axis is capital OM as per the figure. So in the top view we are drawing the section plane in top view only. So look at the axis, top view of the axis OM, which is a point in the top view, and the section plane will pass through 5 mm from its axis. So axis is here, we need to find the shortest distance of 5 millimeter from the axis, right? And in front of it, actually we can draw a section plane 5 millimeter in front of the axis, or we can draw a section plane 5 millimeter behind the axis. Both the cases are possible, but in the question which is mentioned that it is in front of it, that means in front of the axis, that means this region, that section line should be 30-degree inclined to VP. That means in projection which is 30-degree inclined to XY, right? So we need to find the position of that section plane first. So the section plane passing through at the shortest distance of 5 millimeter from its axis. To find that 5 millimeter distance, just draw a circle with the radius of 5 millimeter like this, as the axis, as the center of that circle, 5 millimeter, and then draw a section line which is tangent to the circle. That gives the exact position of the section plane. That means whenever you measure the distance, whenever we measure the distance, the shortest distance from axis to the section plane, it will always remains as 5 millimeter. Okay, so draw a circle with dimension 5 millimeter, radius 5 millimeter, and draw a section plane as a line, and which should be tangent to that circle. Okay, so the section plane is represented as chain thin line with thick ends and arrowhead. Also mention the name of that section plane. This is actually the horizontal trace of the section plane, so HT, right? And this section plane is 30-degree inclined to the XY line in the projection. Right. The next step is to find the section points on the solids. So start from any of the extreme end. I'm starting from the extreme left side. Starting from the extreme left side and moving along the section plane. Section plane first meets the solid at this edge, which is edge AE. Okay, that means the section point 1 is on edge AE, and again moving along the section plane, the second point. Okay, the next time this section plane hits the solid at OA. AE is the base, actually OA is a slant edge. The second point is on the slant edge OA. Again moving to through the section line. Then the third one is on the slant edge OB, point 3 on OB. Again moving along the section plane. Finally, point 4 on base edge BC, right? Then again moving along the section plane, there we have no edges, the solid is completed. Again move back through the section plane. Okay, look at this edge. Okay, when I'm moving around the section plane back to the initial position, we have already named the point 4 for the edge BC. There we have no other edges, so no corners here. Again moving the next point, we have already named the slant edge OB as point 3. No more points, no hidden points, hidden edges remaining. Again moving the next slant edge OA, which is also named for point 2, no hidden edges. Again moving to the solid, the last one, which is AE, that also I have already named point 1. There is no hidden edges. Then moving along the section plane. Okay, that means the section points are 1, 2, 3, 4. Okay, so the newly created surface, that section surface, will be a closed region of 1, 2, 3, 4, 1. Right, so the sectional top view is completed. That means all the top view of section points are completed. Now we have to find these section points in the front view. Right, it's just a matter of projecting those points to the front view only. Right, when projecting to the front view, project the point 1 towards AE. Right, AE is the edge. AE is actually a point here, AE on the same point, so AE is a point, so project that point towards that point. This point will be the 1 dash. A dash, E dash and 1 dash are same point, which is E dash actually. And the second point 2 on OA, project that point 2 onto the slant edge OA. Okay, we will get the point 2 dash over here. And the next point is 3 on slant edge OB, project that point 3 towards the slant edge OB. This one is the OB slant edge, we will get the point 3 dash here. And the last point 4 is on BC, edge BC, project that point towards edge BC. BC is actually base edge, so project up to BC, base edge. So we got the final projection points of the projections of section points: 1, 1 dash, 2 dash, 3 dash and 4 dash. Right, then complete the drawing with sectional top view. That means the remaining portion, I have mentioned the section arrowhead in this direction. That means the area in between the viewer and the section plane is being removed. Okay, that means the remaining portion is this solid, a small portion of these slant edges and remaining all these slant edges and also this base. And for the sectional front view, all the boundary edges will be remain there. Okay, and draw new edges towards 4 to 3 and 3 to 2. We need to hatch the portion, that means a newly created section surface. So just we have already named the section corners in order, so we can draw the section lines or the newly created edges in order only, that means 1 dash, 2 dash, 3 dash, 4 dash, 1 dash. Okay, so 1 2 3 4 1 will be the newly created surface. It should be hatched. Okay, so there is 45-degree equally spaced hatching lines in continuous thin line with 2H pencil, and these portions also remaining in the solid. So this will be the sectional front view. Okay, then the last question is actually they are asking for draw the sectional view, that means sectional front view, sectional top view, and also show the true shape of section. Okay, true shape of section means it will be only visible when we looking from perpendicular to the section plane. Section plane is here. We can look from this direction or in this direction. I'm going to draw the true shape of section over here, that means looking from this direction. So the first step is draw the projectors through the points 1 2 3 and 4, and those projectors should be perpendicular to the section plane, right? That means the line projectors should be perpendicular to the line and should pass through the 1 2 3 4 like this. Okay, I have drawn the perpendiculars 1 2 and 3 4. So we need to find the section points in the true shape of section. That means measure the distance from XY line to the front view point. Okay, I'm going to draw the true shape of section from the top view, so I need to measure the values or measure the distance from the front view only, right? So whenever I'm going to draw the true shape of section, it's there we have a possible overlapping here, so I'm going to draw a reference line over here. Okay, just a couple of units further. Then starting from the point 1, so now this white line is our reference line, which is parallel to the vertical trace of that section plane. Then to draw the true shape of 1, measure the distance from XY line to the 1 dash, that means 0 distance. So draw the point on that reference line only. Then the next one, point 2, measure the distance from XY to the 2 dash. It should be perpendicular distance from XY to 2 dash. This distance should drawn through the projectors from the reference point. Okay, from the reference line to the 2, and the third point, measure the distance from XY to 3 dash and mark it on the reference line to the 3 on the projectors. And finally the point 4, which is in XY line only, that means the distance from XY to that point 4 is 0, so mark it on the reference line only. So this will be the true shape of newly created surface. So we have the points in order, so just complete the region, close to region 1 2 3 4 1 with the straight lines. We are using the straight line in the front view and also true shape of section just because our base is made up of straight lines, okay, which is not cone or cylinder. If which is a cone or cylinder, we need to draw these figures in a smooth curve with the help of smooth curve, but here the base is made up of straight line, so we can just complete the drawing with straight line only. So this will be the true shape of section, this will be our sectional top view, and this one is the sectional front view.